Next question is, for an ideal Rankine cycle operating between the pressure of 30 bar and 0.04 bar, the work output from the turbine is 903 kilojoule per kg and the work input to the feed pump is 3 kg per kilojoule per kg. So here the specific steam consumption is, okay, we need to find out the specific steam consumption, and here the specific steam consumption, they specifically mention the units for that. So what is the unit for that? Kg by kilowatt hour, and it should be rounded off to the 2 decimal places. See, this type of questions are very simple, because the formula we already emphasized when I am dealing the theory. I have emphasized that what is that, the specific steam consumption and the specific heat consumption. These two concepts are very easy, but still many people are committing mistake. Why? Because the simple logic is they are not worrying about the unit here. Okay, so these type of questions you should not miss. Why? Because these are very basic, and most of the people answer this, so you should not miss this. Otherwise, if you miss, your rank will fall here. So here what is given? So this is a Rankine cycle. Okay, this is a simple TS diagram. So here this is a 30 bar. Okay, this is a constant pressure. There are two constant pressure processes, right? One is a heat addition, another one is a heat rejection. So heat is added at a 30 bar and heat is again rejected at a 0.04 bar. And here what else is given? Only the work produced by the turbine is given, and the work is the amount of work supplied to the pump. Only these two entities are given, that is 903 kilojoule per kg and here 3 kilojoule per kg. Even though I am not writing here the unit, these two units are same here. Okay, nothing else is given. So what is asked in the question? The question is asked specific steam consumption. Specific steam consumption. So what is the formula? Okay, I am not going to again discuss that much. I straight away write the formula here. So what is the formula? The formula here is 1 divided by W net. If I write only 1 divided by W net, then what is the unit? The unit is kg. Yes, tell me, kg kilowatt second. Here second is important. Okay, whenever I write only 1 by W net, what is the W net? W net is a net work output in this particular cycle here. But here in the question, we need to find out this in terms of kg divided by kilowatt hour. So the second should be converted into the hour. So whenever you convert a second, how can you convert the second into the hour? Here, see, both sides I will multiply, like in 1 hour how many minutes? 60 minutes. So here 60 and here 60, and for 1 minute how many seconds? 60 seconds. So here 60 and here also 60. So here 60 into 60, 3600 seconds. Okay, 3600 second. Okay, so 3600 seconds will become a 1 hour. So numerator is converted into the hour, but whereas in the denominator we have this value 3600 divided by W net kg per kilowatt hour. Okay, so first of all, what is the specific steam consumption? What is the formula? The formula is, you should not forget this. Even if someone wake you up in the dream and then ask you, all of a sudden you should tell that the specific steam consumption equal to the amount of steam rate, the rate of the steam required to produce the 1 kilowatt output power. See, here we are telling kilowatt. Okay, but whereas here W net always in terms of the, what is this unit? This is a kilojoule per kg. Okay, this is a kilojoule per kg. Okay, don't confuse with the definition with that of the W net, whichever we need to substitute here. Okay, so what is the W net here? The W net here is W net here is W turbine minus W, pump here. W turbine is how much? This is 903 minus 3, that equal to 900. 900, what is this 900? 900 is nothing but kilojoule per, kilojoule per kg. Okay, so here the same thing we need to substitute in this equation. So here if I substitute that value, so how much it will become? This equal to specific steam consumption equal to 3600 divided by 900. And what is the unit? Unit is the same thing here. So 0 will go under 9. How many times it will go? 4 times. So what is the value here? The value is 4 here. Okay, so this is the answer.